geobyte.
Look at the another important problem. A monatomic gas does 100 joules of work when it is expanded isobarically. Isobaric process means constant pressure process. Isobaric process means constant pressure process. Constant pressure process. Okay. Work done at constant pressure is P into V2 minus V1. Since we are discussing constant pressure process where P1 equal to P2, that is equal to P. Therefore, it can be written as PV2 minus PV1. Here P equal to P1, that is equal to P2. P2 V2 minus P1 V1. It is nRT2 minus nRT1 because ideal gas equation is PV equal to nRT. Here it is nR into T2 minus T1. That is the work done. That work done equal to once again nR into T2 minus T1 is given as 100 joules. Okay, that too it is monatomic gas. For monatomic gas, gamma equal to 1.66. How much heat is given to the gas in the process? Heat transfer Q equal to how much? For that, let us take another slide. Heat transfer Q equal to work done plus change in internal energy. Work done plus change in internal energy. NCV into T2 minus T1. Work done plus NCV equal to R by gamma minus 1 minus 1 T2 minus T1. Work done plus NR T2 minus T1 by gamma minus 1. Work done plus NR T2 minus T1 equal to work done by gamma minus 1. The heat transfer Q equal to work done. What is the work done given? 100 joules. Here it is 100 joules plus work done 100 divided by divided by gamma minus 1 gamma minus 1. It is equal to 100 plus 100 divided by 1.67 minus 1. It is 1.66 or 1.67, no problem. 1.66 or 1.67. Here it is actually gamma equal to 1 plus 2 by f, where f equal to degree of freedom. 1 plus 1 plus 2 by f. F equal to degree of freedom 3. Right? So here it is, right? Gamma minus 1. From this I can write that. From this I can write that gamma minus 1 equal to 2 by 3. In the place of that value, in the place of gamma minus 1, we can straight away write 2 by 3. 2 by 3. Here it is 100 plus 300 divided by 2, because this 3 goes up to 150 times. Here is 100 plus 150 equal to 250 joules. That is the answer. Okay. So look at the options. Option C is absolutely correct. Okay. Similarly, look at the another important problem. Asking like this. An ideal gas goes through a process ABCA cycle. Look at that cycle also. ABCA cycle. The process AB is adiabatic. The process AB adiabatic means the governing rule is PV power gamma equal to constant. Calculate the work done in the process AB. Work done for the adiabatic process P1 V1 minus P2 V2 divided by gamma minus 1. So in terms of AB, PA VA minus PB VB by gamma minus 1. Here look at the PA value. PA value is 2P naught. VA value is V naught. PB value is P naught. BB value is V naught. So for deciding the work done, it is better to find the V1 in terms of P naught. Further, the adiabatic rule is PA VA power gamma equal to PB VB power gamma. PA equal to 2P naught, VA equal to B naught. VA means volume at A power gamma equal to PB. PB is P naught, VB is V1 power gamma. This P naught is cancelled. Finally, it is 2 into V naught power gamma equal to V1 power gamma. From this, I can write that V1 equal to 2 power 1 by gamma into V naught. That's the V1. Okay. Then work done. Work done equal to PA VA minus PB VB by gamma minus 1. Of course, it can be also written as PB VB minus PA VA divided by 1 minus gamma. Because look at the options. All options are okay. Of course, gamma minus 1 also given. No problem. As it is, you can take it. As it is taken. So PA, look at the PA value. Pressure at A is 2P naught. Volume at A is V naught. Plus pressure at B. Look at the pressure at B, P naught. Volume at B, here it is V naught into 2 power 1 by gamma divided by gamma minus 1. Okay, from this, what can be written outside? It can be written P naught, V naught outside. If I write the P naught, V naught outside, it is 2 minus 2 power 1 by gamma divided by gamma minus 1. Is this option available? No, not available. Further, it can be written as P naught V naught into 2 power 1 by gamma minus 2 divided by 1 minus gamma. Look at this option. P naught V naught 2 power 1 by gamma. This is 1 by gamma minus 2 by 1 minus gamma. Option B is absolutely correct. It is very important problem. This kind of problem can be repeated. 5-star problem means most expected problem as a repetition problem. Okay. Similarly, look at the another important problem. An ideal Carnot engine whose efficiency is 50% receives heat at 500 Kelvin. If the efficiency is to be 60%, then intake temperature for the same exhaust temperature is an ideal Carnot cycle or engine whose efficiency of the Carnot cycle is given 0.5, receives heat at 500 Kelvin. It is equal to 1 minus T2 by T1. Here T1 equal to heat receiving temperature. Heat receiving temperature. That heat receiving temperature is given 500 Kelvin. T2 equal to heat rejection temperature. Heat rejection temperature. 0.5 equal to 1 minus T2 by T1 500. From this T2 by T1, T2 by T1 in the place of T1, I can write 500 Kelvin. T2 by 500 equal to 1 minus 0.5. It is equal to 0.5. Then T2 equal to what? 0.5 into 500 is equal to 250 Kelvin. That is the T2 value. What it is asking, if the efficiency is to be 60%, then intake temperature for the same exhaust temperature. For same T2, for same T2, what is inlet temperature when efficiency eta 2 is becoming 60% 0.6. Okay, for that eta 2 equal to 1 minus T2 by T1 dash. T2 by T1 dash equal to 1 minus eta 2. It is equal to 1 minus eta 2 0.6. It is equal to 0.4. Then T2 equal to T1 dash. Here it is asking T1 dash. Same step. T2 by T1 dash equal to 0.4. From this T1 dash equal to T2 by 0.4. T2 by 0.4. Here T2. T2 how much? Look at the T2, 250 Kelvin by 0.4. It is equal to 2500 by 4. Okay, 4, 6. Okay, 2, 625. 625 into 4. Correct. 625 Kelvin. It is equal to 625 Kelvin. That is the answer. Look at the options. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. Asking like this. An engine performs 200 joules of mechanical work. That means work given by the engine is 2000 joules and discards 4000 joules of heat in each cycle. That means the amount of heat rejected, let QR be the heat rejected, that is equal to 4000 joules. What is the thermal efficiency of the engine? You are asked to decide thermal efficiency. As you know, thermal efficiency equal to output by input into 100. Okay, if you take the heat engine, look at the heat engine, they the hot source, that hot source, let me write it clearly, this is the hot source, that hot source is maintaining temperature, let it be TH. This hot source is giving required heat for the heat engine. That means heat supplied to the heat engine is QS. Only a part of the heat supplied is converted to work energy. This is the heat engine. The remaining heat is dumped to the surroundings. The surroundings I can say cold source. The cold source is maintaining temperature Tc. That cold source is receiving QR amount of heat. That means heat supplied to the heat engine is QS and heat rejecting from the heat engine is QR. Now let us write the energy balance equation. Energy balance equation is total input energy must be equal to total output energy. Here input energy is QS, output energy is W plus QR. From this work output equal to heat supplied minus heat rejection. Okay. Now come to the efficiency. Thermal efficiency equal to what? Output means work output. Why? Input means heat supplied. Here heat supplied equal to what? Right? Heat supplied from this. Heat supplied equal to work output plus heat rejection. Work output is 2000 plus heat rejection 4000 is equal to 6000 joules. Now the efficiency equal to 2000 by 6000. into 100. It is finally 1 by 3 into 100 is equal to 33.33 percentage. That is the thermal efficiency of the heat engine. Look at the option D. Option D is absolutely correct. Understood clearly? Yes. Similarly,
Geobyte.